Thanks everyone for coming to our GISS lunch seminar. It's bi-monthly, and so, and again, these are informal talks, in which are
Bi-weekly.
Bi-weekly, so every other week. All of our seminars are generally include GISS staff and researchers. And today, our presenter is Cynthia Rosenzweig. She leads the climate impacts group here at GISS, and Cynthia and I work together on projects related to agricultural systems. But today, she's going to be talking about a whole entire other realm of her research that's on the urban networks and climate change. So, Cynthia?
Thank you. Thanks, Angela. And also thanks to the person who switched. Someone else was scheduled for October 29th, and I said, oh, I'd really like to go on the anniversary of Hurricane Sandy. So thanks for whoever that was. I also want to, before I launch in, I want to thank, everything I'm going to be presenting is the product of a whole team, teams of people. First here at GISS and CCSR, the Impacts Group, the New York City Panel on Climate Change, NPCC, that has experts from institutions across the metropolitan region, and then the CC-RUN, which is the Consortium for Climate Risk in the Urban Northeast, and all the researchers who are part of that, who are working on the scale from Boston to Philadelphia. So thanks to everyone there. Okay, but I want to first start with some questions to you all. First of all, who was here in the New York Metropolitan Region 2 years ago today? Everybody raise your hand.
Everybody was here.
No, not everybody, because we also have some international visitors. Okay, so, and I'm going to ask you 3 questions to think about. What preparations did you make in advance, if any, in advance of the storm? That's the first question. The second question is, what did you do during the actual storm? And were those preparations helpful? And the third one is, afterwards, the third one is very critical. Afterwards, did you take any actions, or have you taken any actions to make you less vulnerable to future storms? Oh, and by the way, for the people who didn't experience Hurricane Sandy, think of your answers to those questions for the largest storm that you've ever experienced. Okay, so now we're going to move from the individual level of thinking about those questions and answering those questions, to the New York Metropolitan Region, to the larger scale beyond the individual, to the entire region, and the more than 20 million people who live in this region. And how do we prepare how do we we as scientists help the region prepare for future storms in a more resilient way in the presence of climate change that is already occurring and climate change that is projected to accelerate in the future? So, I'm going to give, here's the take-home points at the beginning. These are the lessons that from all this work that we've been doing, and which actually you'll see started we started working in the New York Metropolitan Region on climate change, vulnerability, impacts, and adaptation in the late 1990s. And so these are lessons over that entire period, but in particular then with the very focused point of Hurricane Sandy. So the first one is characterizing risk of major storms is a challenge, very challenging, and you'll see some of how you probably have been reading also about even FEMA, our Federal Emergency Management Agency, has a hard time characterizing our risk here or risk in any one region. Hurricane Sandy in particular grounded and reinforced and motivated the expansion of the New York City flexible adaptation approach. This is the answer to one of the frequently asked questions by the media to us right during and after Hurricane Sandy. Was New York City prepared? And the answer, it was really hard because they wanted us to say, no, New York hadn't been doing anything, and they hadn't been paying attention, and they hadn't been doing anything. But guess what? New York had been paying attention. They had been doing things. But the way I finally came to answer that question, and you'll see a little also more, is that before Hurricane Sandy, the New York efforts to develop climate change adaptation, climate storm resilience was in low gear. After Hurricane Sandy, it moved into high gear. So that's the meaning of number 2. The third one has to do with the rebuilding and the recovery afterwards, and what actually happened and what is still happening today. And that's, I call that story the tale of 2 states and 1 city. Then that's looking at the regional scale, the metropolitan regional scale, but also then we have our telescoping scales of the governments at the municipal level, the state level, and the federal level. So there's also issues across those government scales as well. And then the 5th one is having science in place and science in time. I'm going to explain what that means, is critical. And the overall lesson is this one, that I really believe that Hurricane Sandy is a tipping point. Not in our climate science definition of a physical process, slow acceleration, and reaching a kind of threshold, but in the social response to the increasing risks due to climate change. So here we go. All right, so the first thing I'm going to do is just do a bit of a chronology of Hurricane Sandy. This is what happened in the immediate preparations. New York City issued the mandatory evacuation of Zone A on October 28th, 2012. Does anybody live in Zone A? We won't ask you whether you evacuated or not. Compliance was not great. But there was that evacuation order. The utilities did bring in crews from out of state because the storm was well forecast in advance. So there was an attempt to prepare in terms of the utilities. And there was also actions by the MTA. They closed down operations. They moved the rolling stock, as did the New York City Rail Transit, above ground transit, as opposed to the New Jersey Transit, who did not move their rolling stock and suffered many hundred thousands of dollars of damage because they did not do that. And they boarded in place sandbags at subway entrances to protect against flooding. These were some of the preparations. Here was the preparation right here at GISS. I told Rito I was going to put one of his emails. So Rito at 11:02 a.m. 10/29/12 said GISS will be officially closed tomorrow. No decision has been made about Wednesday. This was on a Monday. All windows are closed. Printers were shut down, and people are advised to leave early. And this is the weather from Monday at 12:17 p.m. This was the National Weather Service for New York message: hurricane force gusts this afternoon and evening. And the storm hit in the evening, and this is the bird's eye view from New York Magazine of what happened that night. An explosion at a substation at East 14th Street created the blackout for most of Manhattan south of 34th Street. But what's very interesting about this picture is that while there's this huge swath, and it's so amazing. Does anyone live down here? No, did it? Yes? And it was amazing, really, to experience Manhattan all dark with no traffic lights, police at every intersection.
I happened before.
With the other blackouts.
Yeah.
There, yes. But what you can see is here that the power remained on in Battery Park City. Con Ed did not shut service down everywhere because some of the network there is some higher ground there. And then some of the more recent construction also had already put in emergency generators and had moved equipment to higher floors. So this is showing that there had been some preparation ahead of time. But we all know that despite the advanced forecasts and the preparations, there were tremendous damages. First and foremost, loss of life. Over 40 people died in New York City. Of course, for all of Hurricane Sandy, that's much larger. About 170 people if you look at from the Caribbean all the way. but we're focused here on New York City. 80% of those were from drowning, and many of those were in Staten Island. There was major flooding of the 7 subway lines under the East River. 3 tunnels were closed. 90,000 buildings were in the inundation zone, and 2 million in the city were without power. Now, one of the questions that we get asked also is, well, because you're going to see that a lot of these things we had forecast in our reports. That's the pile of the reports over there. But what were some of the surprises? So the surprises had to do with the gas shortages. People just really didn't think that we were going to have that kind of supply chain breakdown on the gas. I think people really were surprised that we had to evacuate the hospitals, in particular in the blackout zone. And then the fires, for example, in Breezy Point. That was really strange that the breakdown in the electrical sparking when the electricity went off caused the fires in that very tight-knit community, and then the fire trucks couldn't get in. So, yeah.
The gas shortage is really unexpected because big cities like Houston, my parents tell me, every time that something's coming, you can see the supply line, the big trucks.
Yeah, I think but in New York, they just really thought this wouldn't happen here.
Yeah, so maybe they were unexpected.
Yeah.
It also dealt with why they occurred. It wasn't
Right.
because there was a supply. It was the boats couldn't get in with the oil.
Right.
Was the first problem, and then the lack of electricity and lack of backup generators at the station. They eventually got the oil in, but they couldn't have the power to pump it out.
So it was a combination of those effects. It was really one of these knock-on, combined effects type, not just one aspect. Altogether, the estimate for the damage is $19 billion in New York City.
How much is New Jersey?
I don't know, I'd have to check. Probably comparable, yeah, probably comparable. Okay, let's turn a little bit just to the storm itself. So, it was quite, Hurricane Sandy brought together all these different, as all storms do, brought together different elements. And to really understand it, you have to look at the different aspects and attributes of the storm, and then step back and put it all together again. So, the first thing is that Sandy followed an unusual storm track, which turned sharply west, and hit, the angle of impact was perpendicular. Most of our storms are not come straight into the funnel of the New York estuary, and so that sharp west turn was very unusual. The winds itself were tropical force when they were here, so it wasn't a hurricane actually by the time it got to us, but they extended 1,000 miles from end to end, which is making it more than 3 times the size of Hurricane Katrina. So this is Sandy and this is Katrina. The storm's pressure was the lowest on record north of Cape Hatteras at 945 millibars. Then very importantly, the storm timing as it came in that evening of Monday the 29th coincided in much of the region, but not all, coincided almost exactly with the astronomically high tide because there was a full moon. So the storm surge combined with the high tide created a storm tide of over 11 feet at the Battery, which is the highest water level on record since 1856. So, let's turn to that part about characterizing the risk of the storm. So, going into Sandy, the delineation of the areas at risk to major 100-year storms was based on work that had been done by FEMA in 1983. And that's what is shown in the blue here. And all the insurance is tied, the insurance throughout the whole country is tied to what the FEMA maps are showing. And it covered about 200,000 New Yorkers looking at the population. So after Sandy, the FEMA realized, and actually before, this is something also New York had been doing before, the city of New York had been encouraging FEMA. They said, we need new ones. And they were trying to gear up to doing it. But so after Sandy, FEMA immediately geared up, and they did a new set of studies, which are done with hydrodynamic models and storm sets, historical storm sets, to estimate the new ones. The new 2013 100-year floodplain cover about 400,000 New Yorkers. So, and I know you probably have read in the newspaper about people's insurance. It like went from very low to very high by previously you're in the floodplain, and then you weren't in the floodplain, and then you were. So coming to the climate change part, so the Sandy inundation area clearly extended, especially in this area in Staten Island, extended beyond the original 1983 numbers. Now, what we do in the New York City panel on climate change is we make projections of sea level for the region. And then we work with the GIS specialists at Hunter College in CUNY to then see, well, what would the estimates be for the areas for the current 100-year, that's the FEMA, adding in the projections of sea level rise. This is for the 2050s. This would again double the amount of New Yorkers, the number of New Yorkers who are at risk in the coming decades. Okay, this is probably the second FAQ that we were asked was Hurricane Sandy climate change? So this is the summary of our answers. So we say that it is not possible to attribute any one single extreme event, such as Hurricane Sandy, to climate change. Climate is by definition long-term average weather. But what we can say is that the sea level rise that we have experienced in the region, which has been over 1 foot since 1900, which is in part related to thermal expansion of the ocean and as well as melting of land ice, in part is related to had a direct relationship to increasing the extent and magnitude of coastal flooding during the storm. Now, it's very hard to say exactly what that portion is. How much of the sea level rise that we've had so far. There's the glacial subsidence, post-glaciation, related to the geological processes to the north of us. And how much is due to the thermal expansion and how much is due to the melting of the land ice is hard to say. But it certainly will have caused an extension of the flooding that we experienced in Hurricane Sandy. Now, the two bottom points related to climate change are, we mark them very clearly, areas of active research. One is the intensity of the severe hurricanes. That's this one, the work of Carrie Emanuel with sea surface temperatures, and these are the power index for the North Atlantic. And there's Carrie Emanuel and others see that have found that there's an increase in intense severe hurricanes. This is widely debated in the literature and lots of active work on this. But they appear to be on the rise and may increase in the future. And also the melting of the sea ice may also be changing the pattern of the jet stream, making westward turning tracks more likely. But we're careful to say these are areas of active research. So what did I mean by having science in place and science in time? So the very first work that we did in New York City actually began in the late 1990s, when the first national assessment divided the country into regions, and Columbia Earth Institute was asked to lead the Metro East Coast, a regional assessment of climate variability and change. And so that's how I actually got started at all of this, because GISS happened to be located here. And they asked me to get involved. That's why I have urban as well as ag. Anyway, we put together this report, Climate Change in a Global City, and it turned out that this was not only the first report that people had really done, researchers had really done, and we worked with stakeholders on it as well, for New York and the New York Metropolitan Region. It turned out that it was the first report that had been done on a major city anywhere in the world. Because up until that time, a lot of the impacts research was more on ecosystems, it was on agriculture, kind of land-based, there were a lot of hydrology studies, but people hadn't begun to focus on, well, how is climate change going to affect people where they live? And where do people live? Right now, over 50% of the people on the planet live in cities. So from this, there's now been a very growing interest in climate change and cities, both on the mitigation side and on the adaptation side that we're talking about today. Anyway, that led to a series of reports which we are here. And what do we in general find? What are the two findings? They can be summarized in terms of the key elements of urban areas: interdependent critical infrastructure systems, right? When we looked at the effects of Sandy, that's obvious, as well as vulnerable communities. And this is a map that was published before Hurricane Sandy, showing the vulnerable areas to such kinds of flooding events. And clearly we were pointing out these are the areas that need special attention. And we have Inland Beach, the Rockaways, Coney Island, Red Hook here in Brooklyn. So the work, the initial work and the work on vulnerability, on assessing impacts, had already been in place in New York. And so, and we also said, we did detailed studies, you can see them in the reports, on the subway system, MTA. Klaus Jacob, our colleague from Columbia, led that part of the work. Beach erosion, Vivian worked on that with the Army Corps of Engineers in the very first MEC report, and of course extensive power outages, and how the energy companies needed to be addressing both not only the mitigation side, but also the resilience side as well. Okay, so after Hurricane Sandy happened, Mayor Bloomberg, not personally, but this is an email from Leah Cohen in December, who said that Mayor Bloomberg and the city wanted to reconvene the New York City Panel on Climate Change, which we did in January, to provide updated climate risk information for the Special Initiative for Rebuilding and Resiliency. This is the actual New York City plan, which was developed to link to the congressional appropriation for New York City. And this was the projections that we made. Instead of, in the MEC report, I think we worked on that report altogether probably 3 years from start to finish. We had to do this one, we had a hard deadline. They said, we have to do it by June 11th. We have to get our plan into the government so we can get the money. And we had to do the projections in 6 months. So that's one of the reasons why I say science in time. It's not just that there's science in place, it's that it takes time to do it. And we have to, when we work with decision makers, we're on their time frame and not our own science time frame, which takes a long time. And if we hadn't had, these are really our this is our third iteration of projections for the New York Metropolitan Region. We could never have gotten this email in December and by June have the projections. That's what I mean by science in place and science in time. And the full report is actually at the New York Academy. It is going to be published in the Annals of the New York Academy of Sciences very soon. We're waiting for the proofs. Okay, so now a few slides on how we actually do the projections. Okay, first thing is we work with the stakeholders and ask them what is it, how do they want them presented, and what are they interested in. So they are very interested in risk-based decision making. And so when we present the projections, we always do them in a distribution. And they decide what percentiles they want to see. So they want to see where the models agree, basically. What's kind of like the middle range of the model outcomes. And these are based on results from 35, these are the CMIT 5, 35 global climate models in 2 scenarios, 4.5 and 8.5 RCPs. So we do the middle range. They also want to know, okay, what's the low estimate? And then they also want to know, okay, what's the highest estimate? What's the worst that the models are telling us? So we do that. We when we look across the models, we see what the direction of change is, and we associate those likelihoods using the IPCC. As much as possible, we try to follow what the IPCC does. And now that the National Climate Assessment is coming on board and online, we also work to have that we're nested within both the IPCC and the National Assessment. We also provide qualitative projections for things that they really want to know that the models aren't very good at telling, like the number of intense hurricanes or things like that. So, but they really need to know that, and they really want us to weigh in. But we're very clear that when we take model-based outcomes, these are the model-based results, and then we're very clear when we're saying these are qualitative projections based on scientific literature and expert judgment. And we also make this caveat. I'm including this. All of these caveats that I'm showing you are what we show the city as well. Model-based outcomes do not encompass the full range of possible futures, which we all know that's true too. So we're saying this, we're clear, we try to be very clear and say this is what the models are saying and projecting for this region now. Just a little bit more, since this is GISS. We do time slices. We added 2100 because New York State Governor Cuomo and his group asked for that, and now we do that. We only use one ensemble member per GCM. We use a very simple downscaling method of the delta method. We take the mean monthly changes from the GCMs, apply them to observe. And for the extreme events, we take those same mean monthly changes to the historical daily data. So scientifically, this is one of the, I think, one of the key questions here, the key challenges to us. And I've had a lot of arguments with people who say the GCMs aren't good enough, you have to give like continental scale, the regions are very large really for the results, right? But we work with the decision makers who are asking us, what do the models say about our region? And so what we try to do is we say, this is what we answer them. We say, this is what the models are showing for your region. These are the caveats around them. But it gives them a concrete set of information that they can actually make decisions on. Otherwise, it's like, oh, it's going to get warmer. How can a city prepare with that kind of vague information?
Yeah, but so, don't you feel that you almost, as a scientist, you just said it yourself, you have this global with a resolution of 100 kilometers, and you want to give something at the level of 2, 3. Don't you think that you have to have an intermediate regional model?
Well, we also test that. We do RCM. We do RCM modeling as well. But RCM modelings have their own set of that in many ways are even more uncertain than the global climate models. So yeah, we often do. Anyway, what we do is we say what we do in regard to this. Yeah. We compare the observed and model values for the current climate. We do all of the due diligence. We do that. We test changes in that surrounding set of grid boxes. They are very similar. We define the radius that we are giving the projections for. We don't do interpolation within that, and we provide the caveats up front. That's how we do it. But let me tell you, the decision makers that we work with are very savvy, and they know what a model is, and they know that no model is perfect. So, yeah, and in fact, I'm going to give you a quote from the commissioner, Emily Lloyd, when she was commissioner of the New York City Department of Environmental Protection, she was head of they manage the water system for 8 million people in New York. She said, this is what I'm quoting, and she actually said this at a meeting in Washington with all the Washington folks there too, during a Republican administration, I might add. And she said, she got up and she said, scientists, get over this uncertainty thing. We make decisions under uncertainty every day. So I truly believe that it's important to give them the information.
Yeah, but let me interrupt for a second. It's true that they agree on their uncertainty, but we, as a scientist, we do know that you cannot apply a global GCM to New York City. We know that. It's not a question of giving them a run around, but the question, I think it's a duty of ours to have an intermediate model that takes the OGCM as a boundary condition and then apply it to a smaller region.
So I want to tell you, Vittorio, we have done that we have done that in much of our work, and I want to tell you that is definitely not the scientific answer to reduce uncertainty. It's
I don't want to
absolutely
reduce
not.
uncertainty. I want to give them. I think that the GCM are not a good tool, but it's up to you.
Okay, let's move to the sea level rise projections. So here, for this latest round in NPCC 2, we gathered a great team, including folks from Princeton, Viviana Gordon, of course, Riley Horton, and others, sea level rise specialists from around the region, and who are very well known and published in this field. And that team created an innovative 6-component approach used to develop regional sea level rise projections. So some is taken from the model, the global thermal expansion terms, changes in dynamic ocean height, that's at the more local level. But then there are other components that affect sea level, including the ice mass, we mentioned the ice mass from the ice sheets and the glaciers and the ice caps. Then there's this gravitational, rotational, and isostatic fingerprinting processes that are now included, the vertical land movements, that's what I was describing with the subsidence, and the land water storage, which here there's some with the reservoirs and the dams, et cetera. There's also change there as well. So these are these sea level rise projections are really up to the minute scientifically. And so I was just at Delta City's conference in Rotterdam, and the Dutch, who were like, is anyone here from the Netherlands? Yes. So the Dutch are, this is like world experts in this. And I felt great because I was in the session I was in, a Dutch researcher gave what the way that the Dutch are doing their projections, and they're basically the same. Actually, I think ours are even better. I think we do the land. Anyway, so those are the sea level rise. Okay, so what do we learn from doing this? And how do we share that information with the decision makers so they can begin to make decisions and prepare resilience for the next big storm? So what do we find? Climate projections illustrate a broad-based acceleration of climate change in coming decades. They show significant climate risks, especially heat waves, extreme precipitation events, and coastal flooding. They are valid for the entire region. And then these are what the models are showing to make it concrete. Otherwise, it's like our eyes glazing over. The annual temperature increase for this region is up to, these are for the 2080s, up to, but they're all in F because of the working with the stakeholders. Precipitation is projected to continue to increase, plus to 5 to 15%. Then these are an example, we put in some examples of the qualitative kinds of information because they really want to know, just like, I'll come in a second, they really want to know, well, what's going to happen to hurricanes? So we say, and these very much follow the National Climate Assessment findings as well. More likely than not, increase in the number of the most intense hurricanes in the North Atlantic, and it's unknown the total number of the tropical cyclones. And what's really unknown is our other big storm, which we didn't talk about at all. The other big kind of storm that we have is nor'easters. Nobody knows anything about how nor'easters may change.
So how come you don't bring in like quantitative assessments like carry manuals or see where the storms?
That's what we do is we analyze all the literature. So there's Carey, Emmanuel, there's Nin Ling. There is Philip Orton. We bring all of them together because it's an assessment. It's not just one. It's not just based on one study. That's how we do it.
And we also use FEMA for the flood return periods.
Yeah, so we don't just pick one study. It's like the IPCC. We look at all of the studies and then say what do we feel is the most robust that we can say.
So it's not really there is quantitative component.
Oh, well, we do quantitative for the model-based. The basically temperature and precip coming from the model, which have are less part of active scientific research. On areas that are still have wide discussion in the literature, we give a qualitative finding. That's how we determine that. See, so these are the actual numbers on the sea level rise.
So it says annual so the temperature rise up to 10.3 Fahrenheit. What's the lowest? So this is only the maximum. And what's the range? And what's the
Dan, can you find it? We didn't want to bore you. They said don't be boring. So everything has tables. Everything has tables. The 10th percentile, the middle range, and the highest.
I guess sometimes it's dangerous to say up to because it might be one outlier which is
right. No, that's the 90th percentile. We'll give you it to right now. This table is an example of actually how we actually show them.
4 degrees.
Yeah. What was it? Say.
4 degrees.
4 degrees. Yeah. Okay, so these are the projections of sea level rise for the region. Let's look at 2100. And the low estimate is 15 inches, so a little bit over 1 foot. Here's the mid-range, 2 to 4 feet. And here's the high end, is about 6 feet. So, but sea level rise itself, well, that's important. What really matters is the flood heights and how this would affect the storm as storms come along and the coastal flooding. So again, working with FEMA's numbers for the 1 in 100-year storm now, which is now 11.3 feet. We compare those sea level rise projections. This is for the 2080s, for the low, middle, and high estimates. We should have just looked at the 2080s. But what we see is that the level of storm that occurs on the order of 1% or once every 100 years, with sea level rise, as we march through the decades up to the 2080s, depending on just a range of either somewhat higher or up to 12% occurrence per year as a chance of occurring per year instead of the 1%. So this is one of the key risks of climate change and sea level rise to the region. So this then translates into, here's the once every 100, once every 60, once every 20 to 50, once every 8 years. Now, turning this around, you can then also look to see, well, what would our 1 in 100-year storm level be in those future decades, in those future time periods with the sea level rise. So instead of the 11.3, that 1% storm becomes 16 feet. Okay, let's turn to the tale of two cities in one city. Okay, Governor Cuomo, right immediately following, established 2100. They were called the 2100 commissions. I served on one of them, and he recognized immediately climate change as an increasing risk. Governor Christie of New Jersey focused on rebuilding, quote, as was, does not recognize climate change as increasing risk. Mayor Bloomberg, leader of the at that time he was leader of the C40 Large Cities Climate Summit. He's now the special envoy to Secretary Ban Ki-moon for climate change in cities. He created the $20 billion Resiliency and Resilience Plan, Rebuilding Plan, that's what I just showed you, the SIRR, recognizes climate change as increasing risk. What does the US Congress do? It required each entity to submit their own plans to receive the appropriated funds. And so we have a balkanization of the rebuilding and the resiliency measures because this is how the regulations. So all cities have this situation that there's a core city and there's a surrounding region. So one of our main recommendations is that the entire metropolitan region has to be, the scale of resiliency has to be done for the region.
But if you can't get the governors to agree, then what do you expect?
Well, it's that's exactly tale of two states and one city.
Shut down the grid, and you don't need the.
What?
Let's shut down the grids, then the other side doesn't matter.
That's an idea. Okay, this one is the one slide which is truly social science, because in all of this we have social scientists working with us. And I'm going to go through this very quickly. This is what they told us that we had to have before we started working on resiliency in the New York Metropolitan Region. Basically, you have to have what they call a conceptual model. You have to have it's a little bit in NASA, we would call it a mission statement. Right? What are we really trying to do here? Okay, I've got to briefly explain this. This is the social science conceptual model for risk management, flexible adaptation pathways. So climate change adaptation is characterized as a risk management issue, and all these managers of all the infrastructure deal with risk all the time. You have flexible adaptation pathways as the response, and they actually call this development of resilience. They can call it whatever they want. So risk is going up, time is marching through the decades with changing climate. This blue wavy line, this is the social science part. It's this group, it's this agglomeration of all of our individual risk perceptions and levels. We all have this embedded, we want the government to protect us to this level. That's what this is. And it changes through time. Because sometimes we feel kind of stronger, we're macho, we can survive a really big storm. Other times, for example, after Sandy, we definitely, in the New York Metropolitan Region, we want the government to do more. That's why this is a wavy line. If we don't do anything, because of climate change, eventually and sooner we're going to cross the level. That's the status quo. Right? Even if we set an inflexible adaptation measure, even with mitigation, eventually, this is like if we build barriers, eventually those barriers are going to be overtopped. And that's kind of what's happening in London right now, as a matter of fact. So that's if you get too rigidly taken up to with just one adaptation. The yellow line is flexible adaptation pathway. So what we're trying to do is, okay, we're going to get started, we're going to do some stuff, we're going to reduce the risk, but then maybe it builds up again because climate change continues. We're going to evaluate, we have to monitor and reassess. We're going to get on a pathway like that, all trying to stay below that acceptable level of risk. Because of climate change, we know that adaptation alone is not enough. It has to be a combination of both mitigation to reduce the ultimate magnitude and rate of change and adapt to the changes that are inevitable, that are already built into the system. So that's why you have to have, we're trying to be on the green line. How did we do it? Okay, so again, we cannot be rigid and only think, people love barriers. That's in the engineering. That's in the engineering part of the portfolio. Some people love ecosystem-based adaptations. They think it's going to be wetlands that are going to save us. Others, I have colleagues who everything is community-based adaptation, and then we have other colleagues who it's all insurance on policy. Clearly, what is needed is a portfolio approach of many different aspects and of policies, social programs, engineering, and ecosystem approaches. And that is what basically New York did in its SIRR. I won't go through all the details, but this is just for the coastal protection. Some of them are engineering, some of them are, here's flood protection structures, including potential for storm surge barriers in some small areas. Here's our natural areas, open space, and of course partnerships. That was the Bloomberg signature of both public and private. So what New York City has done And what it did immediately following Hurricane Sandy and what it continues to do is to work on a portfolio set of approaches. 5 of these have been complete. Dan can find out which ones they are. It would be very interesting. 35 of them are actually in progress, which is really good considering the red tape of actually trying to get the money from Congress. Now this slide is, I'm almost done. This slide is about that part I was saying about how there's the municipal government, there's the state government, and then there's the feds. So this is the NOAA Coastal Mapping Tool, which is, and it includes sea level rise for planning, because after Hurricane Sandy, all the federal agencies wanted to help. And they also wanted to help citizens understand that their risk was increasing due to sea level rise. So the NOAA folks made a map of all the coastal areas of the country. And we worked with them. Many hours of teleconferences, right, Dan? Many hours to say, look, in New York City, we have better sea level rise projections than you feds can ever do. Because we created them locally. And they then took and put, you can see right here, it's on the web, NPCC2 SLR scenarios, so that when there is local information that is better than what the feds have, that then they accept it and they take it. And this is one of our points that around the country and around the world is needed. Okay, so Hurricane Sandy is tipping point. In Hurricane Sandy, this is the overall take-home point. That the acceptable level of risk plummeted in the New York Metropolitan Region. People are now demanding greater protection from coastal storm risks. Investment and action were mobilized by New York City and also New York State and also New Jersey in its own way. The special initiative report the plan that I showed you, the U.S. congressional appropriations, because you have to have money to actually make this happen. And there's a wonderful program that was actually led by a Dutch colleague, Henk Ovik, and it was established by President Obama, called Rebuild by Design. They are creating a transformative new development trajectory that is really working very hard to have New York Metropolitan Region be resilient to increasing climate risk. And this is the point that I believe is the most transformative. Explicit recognition of increasing risks due to climate change in coastal areas are now thoroughly accepted in public discourse. Before Hurricane Sandy, in the United States, I know we have visitors from Europe and elsewhere, but in the United States, there was never any official kind of recognition of increasing climate risk due to climate change throughout the entire nation. And Hurricane Sandy has led the way to that change. This has a major effect on coastal storm protection plan, not only in New York City, New York State, nationally, and even internationally. It's a big deal. So what are the factors? Why is it? Why did it happen here? First of all, the leadership of Mayor Bloomberg and Cuomo, and Governor Cuomo, you need that. There was, to a great extent, not completely, but to a great extent, federal, state, and municipal alignment, finally to get those telescoping scales all pulling in the same direction. And I also think, I'm looking at Sherry, who's our communications specialist, New York is a media hub, and I think that whole part of having all the media here, very experienced in, and of course Leslie and Michael too, having New York very experienced in the media is very important. What's the challenge? Sustaining this, right? Because what happened in January? We got a new mayor. And in democratic societies, mayors' administrations change and always change. And you don't know whether the following on mayor is going to be as forthcoming in accepting, in this case, the climate change issue for one of his major main programs. So in the beginning, everyone was asking us, well, is Mayor de Blasio on board? Is he on board with climate change? And I'm glad that it's actually very good that we can have this now, because, and I do think the Climate Summit and Climate Week and Climate March that just happened in September were very motivating because Mayor de Blasio, around the Climate Week and Climate Summit, made an announcement that he was going to, actually it's like doubling down on Mayor Bloomberg's greenhouse gas targets, reduction target. And the Bloomberg administration was aiming towards 30% reduction by 2050. The de Blasio administration is going for 80% by 2050. That is a challenge. But they're going to work on it, and the first thing they're going to do is work on the buildings, because our biggest source of greenhouse gas emissions in New York City is the aging infrastructure. And that leads me, of course, to right here and what we could do in our renovation right here at GISS. At the same time, he's also working on the resilience part, and he's going to be we're reconvening the NPCC one of these weeks. We're waiting for the announcement, and the emphasis is going to turn in part. All these things that we've been working on will continue, but the emphasis is going to turn also to the equity issues and those vulnerable communities that I spoke about in an earlier slide. Okay, I have 3 more things I want to say. I have 3 endings. So this was the first ending. This are 4 endings. Okay, so basically everything we're doing here, and it's going to be very quick. Everything we're going to be doing here, everything we do here, we do in other cities as well. We work with cities and we work with researchers all over the world to help their own cities prepare for the increase in climate risk due to climate change. That's the Urban Climate Change Research Network. And with them, we're creating an IPCC for cities. That's this. It's called Assessment Report for Climate Change in Cities. These are the references and links. And this is the last slide. So I want to just say something to the GISS colleagues who are here. So we're really in the beginning of a real new phase for GISS, with Gavin coming on board, etc. And we would really like to, so as part of getting ready for the renovation, Angela and Gavin and others helped to make this map. I'm sure you're all going, no, it should be this, these arrows should be different places. But this is an affinity diagram of the GISS research teams. You know, it's a heuristic, really. But the point I want to make is, I really hope that we can, for people who are interested, that we can strengthen the interactions between the science of the modeling, all the other, you know, if it's relevant, the other great science that is done here, to see how we can work to bring GISS science to decision makers, even right here in our local area, but also to cities around the world. We work with agriculture for those who are working on, for example, the dust or there's so many, or water issues, etc. So anything that is there of a connection, we'd love to see if we can strengthen the linkages between the impacts at GISS and the other science activities. Thank you very much. Thoughts, comments? What do you think about, okay, let's talk about this with the model. Can we downscale? What do you think?
I think that if you're going to do regional climate models, it sounds all good and well, except that maybe it's not something local that the region's most important. Maybe the regional modeling off the coast of Greenland, for what developing it's going to be off of Greenland is actually more important than modeling, like, you know, exactly the topography in New York City.
Exactly. Exactly. That's one of the reasons why we've tried it.
But
and also there,
I think
when you have a resolution of 1,000 kilometers, never mind. Yeah, a resolution of 1,000 kilometers.
well, some of the other GCMs are smaller.
Yeah, how can you use that for the New York area? I mean, I think
No, it's just saying.
The weather models, I mean, these are large scale features.
Yeah, that's right.
Well, I mean, the large scale should serve, as everybody does, and no one resist to this tendency that everybody is trying to use the GCM as giving the boundary condition for regional modeling. That's the standard procedure. There's nothing sophisticated, nothing new.
And we've
more than
tried
saying
that.
that's what everybody's doing.
Right.
So the large scale will give you the mapping in Scandinavia, whatever is occurring, but don't tell me that is not relevant to the local thing, because to the boundary condition,
Right.
that will affect
So-
the local region.
Right.
That's, that's
okay.
elementary.
So what we do is we do regional climate modeling as well. And what I think that we have to then, what we try to do when we add in the regional climate modeling, first of all, is be very careful to see what are the larger scale influences, and then what is the RCM actually helping us with. And I do think that there are perhaps some aspects like sea breezes, some topography differences that they can help with. What we found with working on them is that they're also they're just highly uncertain depending on what parameterization you use, what GCM you're forcing it with, and then because they are more computationally demanding, you could never do as many on the ensemble side to really get to. But we do use NARCAP. Are you guys familiar with the NARCAP program? That's the North American Regional Climate Modeling, with how there were multiple RCMs, and we do that.
Just add the balloon in there. You have so many balloons. One more would not disturb. Local. That's all. One more.
I can't have any more balloons in the air.
Absolutely.
I can't have any more.
Just one more balloon, a little bit. Swing the climate model and put them up.
Anyway, so of course Hurricane Sandy will never come again, and of course in that configuration. But it's clear that there will be further coastal storms, and I think that every region, but certainly our region that GISS exists in is very interested in being a leader on developing resilience, but others, but there's lots to learn from other cities as well. The Dutch have had a great role to play in the past 2 years right here in New York. So, and all the cities. Let me just say one thing also. I mentioned this, but so the nation states have been working on a climate change treaty for at least 20 years. And of course, we're all very much hoping that COP21 next year will really come forward with a new treaty. But in the meantime, during all this period, what has happened is that the cities are actually stepping up and creating they have networks in which, and at the Climate Summit, the Compact of Cities, which includes 3 major networks of cities, they put forward their climate action for their targets and timetables for mitigating, because anywhere from 40 to 80% of greenhouse gas emissions come from cities, depends how you measure, of course. So on the mitigation side, they're leading, and then on the resilience side, on the adaptation side, they're leading as well, because they are on the front lines. All the cities on the coast are doing what they can. Let's just go back. This one. All the cities on the coast, they are on the front lines. This is one of the things I say. What is a national leader when there's a disaster, a climate-related disaster? What happens? What happens with the national leaders, right? The national leaders helicopter in, and then they helicopter out. The mayors are there having to deal day in and day out with the recovery. And so that they're much more they are going to actually be the implementers. They're emerging, and our effort on cities is to really provide the knowledge base, the science base that they need to actually fulfill this potential as the actual implementers.
So, with the Hurricane Sandy, a lot of the places that were inundated, they were it was disproportionate on poor places.
Yes.
They're building a low zone. So is there moves by the city council to redo our zoning laws so that we don't put this very mostly on the floor?
Very much so. This is going to be the focus of the NPCC 3 that's just getting going, and the city as well. It was last Friday. They held an event at City Hall that was for the neighborhoods to come together, because that's the Mayor de Blasio's his prime motivation is social programs. jobs and helping lower income. And so what we're really hoping is that we get from Mayor Bloomberg, it was top down. It was very critical infrastructure oriented. And public-private partnerships were running everything really well, which is, a city has to run well, right? But what we're really hoping is that now with Mayor de Blasio and the social programs, that we're going to be able to have both the top-down and the bottom. But it's just getting going. And so we're 5 people are coming on board who are like environmental justice lawyers and specialists to help make that, so that we can help make that happen. And then they have many people in the administration as well.
Yeah,
What are your thoughts?
I just wanted to point out, just as a comment, that at least in the New York metropolitan area, the coastal zone is not necessarily the home of the poor. I mean, the desire to live near the waterfront is a very great motivating factor in the recent redevelopment of our shores. And all you have to do is look around in Lower Manhattan, the Brooklyn redevelopment, and also across the river in Jersey City and Hoboken.
Yeah.
Look at all the high-rise buildings right on the waterfront.
Yeah, that was really coming from the Bloomberg administration. I want to show the map here. So the thing is, no, I think that your point is really well taken. There are enclaves, and there was building up, and through the Bloomberg administration, there was more kind of development for wealthier people. But there is still, when you look at these areas, these are lower income places, and there's very much now a focus on what can we do here. And let me just say one thing. We didn't put this in. It's all, by the way, there's a global environmental change paper that all of this is in very gory detail, that Bill Selecki, the co-chair of the New York City panel on climate change. But there was dissension. I was sort of making out that New York City and that Mayor Bloomberg and Governor Cuomo, really saw eye to eye on everything, but they didn't. And the one thing, the one major thing that they disagreed on was managed retreat. And that leads to, that's illustrated because Governor Cuomo put through a program to buy out very vulnerable places. And one whole town in Staten Island has done so. There's one place that has moved. The place people took the buyouts. But for the Bloomberg administration, this is their definition of resilient, right? Able to bounce back and change after change or adversity, capable of preparing for, responding to, and recovering from difficult conditions. Synonym tough, see also New York City. So there was a difference in opinion, and they did not want to retreat. The Bloomberg administration did not want to retreat from the coast. They didn't want to hear about it. So it will be that will be one thing that will be interesting to see as we work with Mayor de Blasio's administration to see.
You don't need any suggestion, but I'll give you one.
No, we're always open to
suggestions.
suggestions.
But is it your strong point? I mean, 1 month ago, you were quoting Ban Ki-moon during the day in which he had this meeting at the United Nations. The emphasis was on sea level rise. The emphasis, because the island and the Pacific are going underwater. So I think he did an extremely useful job of sensibility study of the people, how sensitive. This has nothing to do with modeling, because after all, this is satellite data that tells you the sea height is increasing. So it's over and above all this modeling discussion that we have. Because sea level rise, you can measure it, right? So that is a very strong point. It is part of what you said.
And we do sea level rise. But what about the inner cities that the high temperature effects are extremely damaging to the elderly and the poor? So and the very young. So because the poor people can't afford to have air conditioners, often there's social isolation. I think
exclude them. I'm saying
right.
to give more emphasis
Right.
to sea level rise, because at least that's a phenomenon that you can measure, which is way above.
In each city, but what about the inland cities? Which, by the way, all cities are basically on a waterway, and the intense precipitation, which is a robust finding from it is a robust coming from the models.
Those are These are the robust
Yeah,
things.
it is. So, every city though has to determine its own climate risk information, climate risk, and then develop its resiliency programs. And they have to track it through time. That's why we started ARC3, to have
Yeah,
that
but
benchmarking.
let's be honest, if next Tuesday this government goes into the Senate goes in the hand of the Republicans, everybody's predicting. Yeah, I mean, it would be a different temperature altogether.
You know, we've lived through though.
We did.
We've
We all
lived
did,
through
yes, I know.
administrations come and go, and I believe really, and I think GISS does. GISS has kept this going through thick and thin, no matter what administration.
I know, I know, but for 2 years,
you
they
know,
would make
there
your
were
life
some-
very miserable. I mean, not
Well,
yours,
yeah.
her life.
Yeah,
So, so that's why I'm saying
Get
that,
ready.
that in such a climate, I mean, I hope it will not happen, but if it does happen, as everybody's predicting, I think there are very strong points in your presentation that nobody can deny. I mean, the sea level rise, for example, or precipitation, those are very,
yeah, and we do.
those are very strong
Yep.
statements.
Yep.
And
It's
no
a good
senator
suggestion.
can come up and say, I don't believe in it. Well, I'll give you the measurement.
Right. But you know what? The cities are increasing. Also, all the cities are having temperature rise. Also, it's.
Yeah, I know.
They are.
I know.
And it's a combination of climate change and the urban heat island.
They
So
all
it's
do.
actually exacerbated on the temperature rise.
Yeah.
So, and the so you know, I think it's actually good to look at the climate system and help city decision makers understand their climate system. In our theory, we have a whole thing about the modes of variability, because a lot of times, you know, hey, what's going on with NSA, what's going on with NAO, and for those European cities, et cetera, those decision makers need to know that information.
I just want to comment about that. For example, take the city of Norfolk, Virginia. It's a very conservative city because, you know, of the
It's Virginia, yeah.
Navy
Where is
base
that?
nearby and so
Yeah,
on,
yeah.
a very strong military presence.
Yeah.
Nevertheless, it is subsiding more rapidly than just about anywhere else on the East Coast.
Really?
And
Oh,
they are
yes.
subject to increasing flood risk with even relatively minor storms. So they don't want to know about climate change
Right.
or sea level rise, but they're very well aware of the fact that there's increased coastal flooding. So that's the problem that they will be dealing with, even if they don't like the label of
Right,
climate
right.
change. Or they're not going to ascribe it to that.
But in any way, somewhere you're making my point. There are some very solid facts that are over and above any scientific uncertainty. They're true. That's the one we should focus on. Yeah, you're making my point. I agree. I agree.
But do you think like the South Ferry renovations of the station, like that was after you guys had already
Yes.
said like, oh, sea level change may be a problem. They went ahead and they put $100 million into that place. Now that Sandy's happened, do you feel like the scientists get to have more of like a veto power?
Absolutely, absolutely. Yes, oh, for sure. I went to, it was probably like, I don't know, probably March or April, when I went to, at the MTA.
Oh, yeah.
And it was probably in April, just, that's of 2013. And it was this kind of like, it was this round table, and it was the chief engineers of the 7 MTA divisions, because there's the buses and the subways and the bridges and whatever, all the ones. And the chief engineer, who was a fantastic woman, by the way, basically within the agency, it was saying, we are now going to take climate change risks into account in everything we do. And I did the same for the New York State Department of Transportation. So it has to come from the top, but it is. And that's why I say it's a team. Because they are. And it's not just rebuilding the same old. They all know that they have to rebuild plus. And then that decision of how much to rebuild, that is on the decision maker's side. But at least they have the science information.
So this patchwork, like I know my stations around me, they flooded during Sandy, and,
Yeah.
and now they've got some sort of patchwork. There's been track work. What is that? Is it? I mean, they don't tell you what it is, but is it something that's going to be useful, and how much resilience is it going to give us?
I know. Well, we'd have to look at this. Maybe we should get Klaus in, because Klaus Jacob, our colleague from Columbia, from Lamont, he works very closely with the MTA in their exact plans. So we could have him come, and you could ask him that exact question. But one of the problems is all this costs money. And so then how do you prioritize? What do you do first? And how do you make a plan? So one of our main recommendations is all infrastructure has a capital return period of that they're going to, in 10 years or 20 years, they're going to rebuild. So that's why it can't happen all at once. But what we say is, when it's the normal capital cycle, then go in. At the same time, the SIRR is the most critical and crucial things that they're working on now. And let's look and see what those 5 really are. What did they choose to do first? What are they? I think that, is that we want to, and we'll be doing that in the next round. It's like, okay, because we're starting by the way, for a long time, and this is, I think, germane to the discussion. The climate change issue was, we were in the issue identification phase, right? Jim going in 1988 and saying, climate change is real, right? And it has taken so long, decades, right, for it to spread through society. And of course, each nation is in a different place, or each group of, the groups of nations, and the U.S. is a very particular and very important player in all of that, and where we are culturally. But certainly, this acceptance of increasing climate risk in the rebuilding of as large an entity within the United States as the New York Metropolitan Region has gone a very, very long way to basically saying, and it doesn't matter whether people believe in climate change or not. It's just like, okay, these risks are there, you have to do something.
Yeah.
So that's where we are. There's much that now of, is this real? All those, and it's so uncertain. All that. I think that a lot of that is passing. It's like basically, okay, we have to deal with this now. By the way, we just have tomorrow. Is it? When is the paper coming out? The VAMS? Tomorrow, the Bulletin of the American Meteorological Society, we're having a paper come out on developing resilience at NASA centers across the country. So it's so look at that.
Didn't they just spend like $100 million or something crazy down there? Is it Wallops? They did all
Wallops,
these buildings
yes.
like at low level?
Yep, and Dan was at the climate change conference there, the workshop there. Yeah, they took sea level rise into account on that study, on that rebuilding. Yep. We're part of that. So NASA is also working on this. So we work with cities, but we also work with the NASA centers and the regions. Anyway, it's like, thanks everybody.
Thank you.
It's really good.